Welcome back to the course. In this video we are going to go over the solution of the simple single user to-do list API, the exercise that we had just seen in the previous video. This is not, well, actually I said the solution, but it's just a solution, my solution, and it's probably not even the best one. But we're going to go over, because there are a couple of things that I've used here that I haven't actually taught earlier, but I figured it would be better to use those features than others. While this is a working solution, definitely it's not going to be the best solution. I'm sure you will encounter issues with it. And I'm also sure that you have already, if you've managed to solve this exercise, then you probably solve it in a slightly different way, or a lot different way. So first of all, I would recommend that you only review this video after you at least attempted to solve the problem, even if you haven't managed it. But if you have managed, that's even better. And then look at how I solve it. And I would really be happy to see your solution. And if it's okay, then it will probably be able to share it with the other students of this course to see how other ways to solve this problem. So let's go over the exercise, the solution that I have here. This is the app.psg file, and I also have a test. And if I switch for a second to the command line, where you can find, you can see ls-l, you can see that I have these two files, and I can even run proof test t, and it will print out a couple of debug messages. We'll look at them later, and it says all tests successful, so everything fine, the tests are working. Okay, so we are going to go over now both the solution and the test. The main route slash it just returns the text to do, is just an HTML, doesn't really matter, it's not really part of the exercise. The first thing that's interesting is the first route that you can see here, how we get the text that we want to add the new to-do item to the database. Okay, and we didn't discuss the database yet, but we'll do. So /API/add some text. This is the URL. From the route parameters, we can get the text that this part of the URL that the user typed in or sent in somehow. We save it in the $text, and then we use the vars hash, basically. Yes, that's a function that returns a hash. Okay, that's the more precise explanation, I guess. That is provided by the answer2, and we haven't seen that because we earlier I used the set and settings pair. But that's primarily for settings. This vars is a tool that allows you to pass various variables or data from between the hooks and between the route, the main route, and that's what we are going to do. That we are doing here. So we're taking the $data from vars arrow data. So it's a reference to a hash, and it has a key called data. But where does it come from, and how does it work? So if you scroll down a little bit, or to the end of the code there, basically, here we have a hook before. So this hook will run before every route, and here we use the var keyword to store a variable name, a key value pair. So a variable name, basically an entry in that hash, and some value. So the first one we store is the start time, which is just the result of the time high-res time function. So it's a high-resolution timestamp. Then we get the name of the database file. So we are going to use a JSON file as our database. Yes, we could have used an SQL database, but I didn't want to go that far in the application. So just a plain JSON. We don't need to know SQL for this. And as you've seen in earlier exercises and solutions, here I have an environment variable, which is I called now TODO. And so you can provide the name of the file, especially for testing, it's going to be interesting, as an environment variable. And if it's not provided, then the name is going to be todo.json, locally in the same directory where we are running. Okay, and actually this could have been improved by calculating this one, so it's going to be always next to the files of the application. So that's something that could be improved. So this is where the DB is stored, and the dollar, and it's stored in $DB, and I'm storing it in a variable called DB. Still not the data. The data comes here at the end. And then where is the data? So the data is going to be basically our data or database, okay, which is just a JSON file that starts out or defaults to an empty reference to a hash. But if the file exists, so if the DB file exists, the database files exist, then we open it, we go into slurp mode, read the content of the file, and then decode the content, because that's a JSON string, into data. So we are assuming that, well, there's a JSON data structure in this JSON file, and that's going to be the data, the dollar data, and we store it in with this variable var data and this dollar data. Okay, so that happens before, and that's how we get to this point that in the route, in the first route that we were checking, we can access it with vars and then arrow data. So that's that reference to a hash where we can access it. So it's a function that returns you a reference to a hash, and then you can access the elements like this. So this is the data. Then this is how we get the ID. So now when you send in some text, we need to generate some ID, and that's how we're going to store in the database that this to-do item, this item has this ID. Now, of course, you could, if it was a real SQL database, then probably I would have a primary key that's incrementing automatically on every insert. And here also in the JSON file, I could have some counter, but I said, okay, I don't need all this complexity. I'll just take the time, the current time with the time high res, multiply it with some big number, okay, and take the integer. So it's 1,000,000, I see. So it is going and take the integer part. So it's gonna be a big integer number. Of course, yes, I know if two requests come in exactly the same, I think it's microsecond, then it's not really a good idea to do this. So that's not a perfect solution, but good enough for at least our exercise, and probably for a long time it would be enough. Actually, if I was worried that there are duplicate IDs, then probably I would I check that this ID doesn't exist, but I didn't care about that. So we have now the ID, and I add to the data that key. Okay, so the data is a reference to a hash. I add to that key and the text. So in the database, we are going to have basically a hash database, yeah, the JSON file, which is a key value pairs, the ID, and the text. Nothing else in this to-do application. There is also a commented out line here where I debug a message, so I print out a log message and debug level the ID, but it's commented out. You can enable it if you're interested to see this. And then we call the function which is called save data, that gets the database file. Basically, I think maybe, yeah, okay, maybe I could have used it inside there. Okay, so I'm not sure that I really need to pass it. Maybe I could just access vars in that function. Okay, I'm not sure that's available in this function because it's a separate function. It's not a dancer function. And I pass the dollar data. Okay, and let's see what the save data does before we go on. So the save data is just receives the database, opens the database file for writing, and then encodes the data as a JSON and saves it in the file. So that's basically just dumping the data as a JSON in this file. So back to the beginning, and here we save the data, and then we construct the response, which is going to be a hash, okay, with the key status okay, and the ID that we just generated. Okay, maybe you could add also the text, but I didn't want it. Okay, so this is going to be the response JSON, and then this is how we send in the response that you saw in the previous video. We set the header to be application JSON, the content type in the header to be application JSON, and then encode the data, the reference to this res, encode it as a JSON, and send that back as a response. So this is how we add an item. Now, before we go on seeing the rest of it, let's see how can we test it. In the test, we have a couple of modules here. Okay, the first thing is that we create a temporary directory with cleanup, and the database file is going to be in that directory. Now I'm using the pass function here. I am surprised that I wasn't using it inside answer. That comes from path_tiny. It's like the cat file. So it takes a directory name and the file name and concatenates them with the appropriate slash for your operating system. So this is going to be the DB file, and I assign it to the environment, to the proper environment. So the application will see it. And this is not interesting for now. And then here is the test. Okay, so actually this is just the testing the main page. That's not interesting so much because we have seen it plenty of times. This is the test that is checking how adding a value new item works. So we take the plug test, create application just the same way as we did earlier. So this is going to be like a web client thing that you can use. Okay. Then we unlink the database file. So this is, I put it here at this point because this is the first subtest. The database file is probably not there. But I wanted to make sure that if the file is there, then we remove it. So the first test will happen when the database file doesn't even exist. I wanted to test that case. Okay, so this is the text that I'm going to send in. This is the request, get request, API add, and that text that we are sending in. And we get a response from this addition. I think at one point I wanted to have multiple of these requests in here, and that's why I have res add. I probably can just rename it now to res as we had in earlier exercises. We check that the status line is 200. Okay, here I have the diagnostic message printing out the content. That's what you actually saw when we run the tests here. So if I run the test again, this is what you see here. Okay, this is the message that was received from the application. Okay, and now we are testing whether this is actually correct. So we take the response, which is just some JSON string, decode it. Okay, for this we need a decode JSON, and that we are importing here from JSON maybe XS. So we convert it to the Perl data structure response add, and check if the status is okay as we expect. We also check if the elapsed time matches some regular expressions. So this is also that we skipped over earlier. I put here a regular expression that checks whether the elapsed time is something that looks like this, some digits, a dot, and some more digits. And the reason I put it in a separate variable and outside is because I'm going to reuse it, and I didn't want to have that in the every regular expression. It would be an even better, more improvement to have a separate test function that just checks if the time is okay, and then I wouldn't have to have all this thing here. Okay, I also get the ID. So remember, the data here is the ID, the elapsed time, and the status okay. So we already checked with the status okay. We check where the elapsed time is something, and then now we are checking the ID. So here we fetch the ID, and we check if the ID matches this regular expression, which is basically just 8 and more digits. Okay, so digits, 8 or more digits from the beginning to the end. So it's okay. And then we also print out the message, just printing out this number. Okay, and then comes the final part, that we not just check that the response was correct, because in the response we don't really know the ID, but we also look if the database was updated properly. So what we do is we take the DB file, Okay, so this is the same DB file that we created at the beginning, that we also assigned to the TODO DB, so the application will be able to see it. And then we use the pass from pass tiny and call slurp on it, which will just read in the content of that file, decode the file with decode JSON, because that's a JSON string. This is the JSON, this is the data, okay, from the database. And then we compare if that database is the same as the ID that we got back from the user and the text. So whether the response that we got back from the web application here matches whatever is in the database now. Okay, and remember we started with no file there, so now that's what saved. That's what is saved. And this is the first test case that starts from an empty database or a not existing database, and then checks whether the add request added the data, if the response was correct and if it was stored in the database. Going back to the application itself, let's look at another route. The other route is the get route. So the get route will get an ID and then return a JSON containing the text and some other and the ID itself and the status okay. So and the elapsed time. Okay, so actually where is the elapsed time from? Okay, I haven't showed you because we haven't added the elapsed time here, but the test was testing it. So if you scroll down again, there is an after hook. Okay, and this after hook adds the information to the JSON file, to the response. So this is the response that we have. The start time is that we stored in the variable start time in the first hook. So here we stored it, and then if this exists, so it's just precaution that if the start time doesn't exist, then we won't try to calculate it. That probably should never happen. So we call the time function again and deduct the start time. So this is the elapsed time what we have. There is some debugging messages here, and then we take look at this part. Okay, we take from the response we take the content, which is supposed to be a JSON, right? Decode it. This is the JSON that was already actually sent, but it didn't reach the user yet. Okay, so it was sent from the route, and then add another key elapsed and the elapsed time, and convert it back to JSON and replace the actual content with it. So now added this new field to every JSON. The thing that the reason that I put it into this if statement is that I wanted to make sure that it only happens if the content type is application JSON. Because you remember, there is this main route that just returns HTML, and I didn't want to try to do this for that route. So this update part will only happen if the application JSON. I mean, it could have been around this if start as well. Maybe that should be outside. Doesn't really matter. Both ways it works properly. Okay, so this is the end of the add method. Then we also need to deal with the get method. Okay, so the get method will get the ID, an ID. It can access the ID from root parameters get ID in the $ID, and we get the data again from the database. And before every route the hook runs, so this data will be filled before every route. Okay, so here we get the data from the database, and we check if the ID exists. If it does, then using that ID we construct the response, which is using the ID field with the ID value, the text field taken from the database, and status OK. And if the field doesn't exist, so if that ID doesn't exist, the user provided an incorrect ID, then we set the status to 404 not found, and the response to be ID and status failure. Okay, and then once we have the response, we just set again the content type to application JSON and encode it into a response. So this is how the get works. So let's look at the test for it. The text, okay, there is another version of the testing the add method. I will get to it. Here is the get pass. Okay, so API get, and I have two actually. One is a good get, and the one is a bad get. So the good get is going to get an ID that actually exists, and the bad one will I will send in an ID that doesn't exist in the database. Where do we have the database? So we have a hash here at the top, okay, that I saved, which is some data that is going to be in the database for our test cases. So that's as if the database was already there. Okay, so this is just a couple of these IDs. The IDs can be anything. Okay, we didn't have any restrictions for the IDs and some text. So in this test case, what we do, the first thing is take this data, the reference to it, encode it as JSON, and using the pass from PassTiny, we spew it out. So we save it basically. Okay, this is the method. This is the method how to save basically the content into this file. So this will create the database file, the DB file. This is a JSON file with the content of that hash that you saw at the top. And one of the fields, one of the keys, one of the IDs was I123. So this is the ID that we are going to test. The GET request sends in the ID. The response checks, in the response we check if it's 200 okay. We also display the content with diag. Decode it because the content is JSON, right? I mean, I didn't check here whether the response, the content type is application JSON. That could be also something that could be tested. And then we check where the content, decode the content, which is JSON, back to the response variable. That's just a reference to this hash. And then we have to separate here. So the elapsed time we can't really test properly because that can be any time. The only thing we can test with the elapsed time is if it's the correct format. Okay, and this is actually did I do this the same here? No, I didn't do that because here in the previous test I tested each field separately. This time I wanted to use the isDeeply to test them, and but we can't compare properly the elapsed time because the elapsed time just matches some regular expression. We can't really know how long it's going to take to the elapsed time for when the test runs. So what I did is I took the elapsed time and I created a test just for it, just for that elapsed time. So I run like, which is a regular expression test, the elapsed time here, and that regular expression that you can see at the top, you might remember that let's show you again. So this regular expression that checks whether it looks like some digits and dot and some more digits. So this is how we test the elapsed time. Then we remove that from the response hash, and then you can use the isDeeply on the response hash, which now doesn't contain the elapsed time, but it should contain status okay, the text from the database that we stored, right? So it should be, the response should come from exactly from the database, and the ID that we used. Okay, so that should be the JSON. Okay, and we can also check, it's not really necessary, but we also check here whether the database is exactly the same. The database on the disk is exactly the same as the database that was stored in it. Okay, so this basically checks whether getting the data from the web server doesn't change the database. Okay, it shouldn't, and that's good to test it. So this is how I'm testing when a request with a good ID, and here a separate test for bad get. So when the ID is not something that we have in the database. And so that's what we have here, API get ID again, but this time we check with the status line to be 404 not found, and the response, again the elapsed time was checked and then removed, and then the response should be status failure and the ID, okay, because there's no data. And again, we test whether the database on the disk didn't change. And that's the major part of it, I think. Let's go over, let's see if there is something really interesting, something else here. So in this one, okay, in this listing, so this is how it lists the data. We just, it doesn't have a parameter. It just gets the data from the database, okay, that was already loaded by the pre-hook, the before hook. And the response is status okay. And then we use this construct to create basically a list of items, an array of the items instead of because in the database we have a hash, key value pairs ID, but here in the way I wanted to send back is a key code items, and then the value, which is an array of little hashes where we have ID text. So that's how it works. And then we set the content type again and the encode JSON. In the test, where is the test for it? Here is the test for it. Again, what we do is we store, again, we start with the database from that hash, from the data hash. So we don't want to rely on whatever was in the database after the previous run test. That makes it easy to later split these tests, or run just this test, split it out into a separate file, and then we have, each test can be its own file, and then they can run it in parallel and so on. Okay, so we get that. We get the items. It's a quite similar statement, so it's not really good because now I have the same code in both the test and the application. But this is because it's such a simple version of the things. Okay, if it was the real database, then it was probably different. And then the same, everything is more or less the same. We have removing the elapsed time and checking it, and then removing it. And then we check also with, now this time, compare deeply the items. And now what is this compare deeply? So that's the interesting part. The compare deeply actually comes from test deep. Okay, I think I mentioned, but I'm not sure, that the is deeply function that comes from test more, which we also use it here, is good if you have a fixed two fixed data structures that you would like to compare. The problem we had here is that the order, because the database is a hash, so there is no order in the database. And at least in my requirements or in my plan, I didn't want to have an order for the to-do items. Okay, maybe there should be. It would be better if they are sorted by their ID, but I didn't think about that. So I don't have an order in the application. So, but it's still an array. So how can I compare now two arrays? Okay, the items. One coming from the application, one that I created here, that are both based on the same hash, but because the way the hashes in Perl work, that can be in any order. Okay, so the keys, when we get back the keys, they can be in any order. We haven't sorted them. So that's why it's very useful that we have compare deeply, because here what we say is that this hash, the reference to this hash, is equal to this hash that has the field status which equals to OK, and then items, field items, that equals to some reference to an array, but the order doesn't matter in that array. Okay, so this bag tool that comes with the CMP deeply from the test deep module allows us to compare two array references regardless of their order. Okay, so this means basically that whatever we got back from the user, from the application, and this, whatever we have here, contain the same element, but we don't care about the order. So that's a quite useful way for testing. And the last one that we have is deleting the items. The basics here in every case is that before every test case, basically at the beginning we set up the database file in the first and then so at the beginning we set up the JSON file, the database file, and at the end we check whether the database file is as we expected. So after deleting an item, so this one is a bad delete, okay, trying to delete a bad item that we don't have, so the database should be the same. In this, the good delete, we have the database, and then we are going to remove the 1, 2, 3, and in order to compare that, what we have is that we take we take the file, the database file, and then we would like to compare it to the data that we already have here. So the JSON contains the actual database, okay, already not in JSON format, but that's what comes from the JSON database, and this is the data that we have prepared at the top of our test file. But we want to, but this one will contain also the item that we've just deleted. So we can't compare them. What we can do is we can remove from this data the item that we also deleted via the application and compare those two. But I didn't want to delete that from the data structure that we have in the test script. So instead of that, I used the declone function that comes from storable. Let's go to the top here. Storable, okay, it has a declone function, and this will create an exact replica of this whole data structure. So the reduced data, the variable reduced data now contains a copy of this whole data structure, and in that reduced data we are going to remove the ID, delete, and then we can compare the JSON that comes from the file, from the database, to this reduced data. That's what our expectation. So our expectation is to be that the database is going to be the same as the original data, less the one that we have just wanted to delete here. Okay, and that's how we check it. So I think that's basically the whole testing. This video got really long, but I hope that it helps you learn a couple of things the way I do. Again, it's not the best way probably. I already encountered a couple of things that I would improve, but I hope that you will have a much better solution. See you in the next video.